A quick review of matrices. First of all, if two matrices are equal, all corresponding entries must be equal. So if these two matrices are equal, the number that's in row 1, column 1 of this matrix has to be equal to the number that's in row 1, column 1 of that matrix. So we have the equation 4x minus 3y equals 11. And the same thing, the number that is in row 2, column 1, has to equal the number that's in row 2, column 1. So now we have another equation, x plus y equals 1. That's two equations with two variables, and so we'll solve it using substitution or elimination. Pause the video and see if you can solve that system on your own. If you solve that by elimination, one way would be to multiply the second equation by 3 so that you can eliminate the y's. And when you do that, you should get a solution of x equals 2 and y equals negative 1. Whenever we solve systems, your final answer should always be written as an ordered pair. Then we move on to operations with matrices. If you are going to add or subtract matrices, they need to be the same size, and then you're going to add or subtract the corresponding entries. By same size, I mean the same number of rows and the same number of columns. So this matrix has 2 rows by 3 columns, so it's a 2 by 3 matrix, and this one also has 2 rows and 3 columns. So these two matrices have the same dimensions, or they're the same size. To add them together, that means we just need to add together the entries in the corresponding spots. So 8 plus negative 6 is 2. Negative 4 plus negative 1 is negative 5. 2 plus 0 is 2. And then we'll do the same thing in the bottom. If you're subtracting the matrices, it's the same process, but instead of adding the numbers together, you're going to subtract the numbers. And you need to be really careful with the negatives. For example, 8 minus negative 6, when you're subtracting a negative, that's really like adding. So that's going to equal 14. Pause the video and see if you can finish up that first example and find all of the entries here in the second example as well. When you finish that one up, for this matrix, you should get numbers that I thought would be there in just a minute. Sorry about that. You should get 4, 5, negative 5. In this one, when you subtract, you should get negative 3, 2, 2, negative 3, and negative 5. Multiplying matrices are a little bit more difficult. But first of all, it's pretty easy to multiply a matrix by a constant. If we have a matrix and we're just going to multiply it by a number out front, that number is a constant or a scalar, you're just going to distribute that constant to all the entries. So in this case, we're going to multiply all 6 of those numbers by 5 to get our answer. Multiplying two matrices is a little bit more difficult. First of all, the matrices are not going to be the same size necessarily when you multiply them. The number of columns in the first matrix must match the number of rows in the second matrix. The dimensions of the answer will be the rows of the first by the columns of the second. Let's stop there and talk about that part. So in this example, the first matrix has 3 rows and 3 columns. So it's a 3 by 3 matrix. This second one has 2 rows and 3 columns, so it's a 2 by 3 matrix. And this says the number of columns in the first has to match the number of rows in the second. And in this case, it doesn't. So we can't multiply these matrices together. This would be impossible. If we flip-flop the order, though, then it is going to be possible, because this 2 by 3 matrix can be multiplied by a 3 by 3 matrix, because the number of columns of the first match the number of rows in the second. Those two middle numbers on the dimensions match. Then it says the dimensions of the answer will be the rows of the first by the columns of the second. So our answer is going to be a 2 by 3 matrix. It will have 2 rows and 3 columns. So how do we actually figure out what those numbers are? We're going to multiply the entries in the rows of the first by the numbers in the columns of the second, and then add those numbers together. So if we're doing rows by columns, there's the first row, first column, and what we get will go in the first row, first column of our answer. We are going to multiply 8 times 0 plus -4 times -2 plus 2 times 4, and add all of those together, and that one number will be the number that goes in first row, first column of our answer. It looks like in this case that's going to be 0 plus 8 plus 8, or 16. Then I want to get maybe the number that's still in the first row but now in the second column. So I'm still going to use the first row, but I'm going to move to the second column of the second matrix. And I'm going to go through that process all again. So to get that number, I need to multiply the numbers in the rows by the numbers in the column. 8 times 1 plus -4 times 3 plus 2 times 4. Then multiply and add all of those together. In this case, that's 8 plus -12 plus 8, or 16 minus 12, which is 4. Then you just keep the process going. So then we would do the first row times the third column, and then we'd move down to the second row and take that second row times all of the columns. Pause the video and see if you can finish multiplying these two matrices together on your own. The answers you get when you multiply it, you'll have a matrix that is 16, 4, 12, -22, -14, and 16. The work that I used to get each of those numbers is there.